everybody hear me? Awesome. Thank you for the feedback. Let me just share my screen and we can start. Okay, can you also see my screen? Awesome. Thank you also for the feedback. Okay, guys, so yeah. I think some people mentioned they can hear me, so it should be able to, that should be able to be the case. So can everybody hear me? Okay, good. So I'll actually start. By the way, you can ask questions in the Q&A panel and in the normal chat. I will have specific sections in which I will try to answer them, but you can ask them as you can ask them as we go, and I'll look at them when whenever I make those breaks. So let's actually start. So first off, again, a little bit about me. Just like I mentioned last time, this is my profile. I finished marketing. I went into a business analyst position, then decided to transit to make a transit to a developer role. I did that. Started investing as well, actually kind of a passion. And now I got into blockchain because I think it's a really interesting bridge between investing and technology. Good. Today's table of contents, just as it was presented in the email, will be smart contracts versus real world contracts, risk of smart contracts, also some ways to prevent those risks, and then some business considerations for developers and regarding developers, and some business considerations as in verticals for companies who want to get into blockchain as a whole. And at the end, we'll have a demo in which I will go through. You'll see it's a neat demo. It basically uses smart contracts implemented on Solidity, on Ethereum, using React as a front end. So yeah, let's start. So in case if anybody hasn't seen the first episode, it's online, it's recorded, you can go check it out. The same thing will happen to this one. So probably it would be good if you haven't seen that one to go take a look at it and maybe rewatch this again. So it would clarify some aspects you might have. Again, you can still ask those questions, but if there are questions related to that session, I'll just redirect to that session because we can't re-explain everything because it will just take a long time. These were the aspects we covered. We spoke about what is blockchain at the base level. We spoke about some things happening, which is a bit more interesting in terms of technology, which is hashing and forking. We spoke about, let's say, the main consensus mechanisms, or rather the first consensus mechanisms, because at this moment we have so much more of them, proof of work and proof of stake. Then we asked the question, do we need blockchain? And we mentioned some aspects about the societal need of blockchain, what its benefits are. And then we looked at technical and privacy related aspects of blockchain. So why the technology is important and interesting, and at the same time, okay, what does it do to privacy? Is it either everything open, everything closed? So yeah, things are slightly more clarified there. Okay, so we'll start this session by asking what are smart contracts. By the way, I will presume that everybody here doesn't have a base knowledge on smart contracts, so that we can take it from a lower level and maybe we'll build up to more complex topics. So first off, sorry, before doing this, actually, no, this is good. Smart contracts in a super nutshell is, so first off, they are pieces of technology. So they're not legal contracts. We'll see that when we get to the comparisons, but the idea is they're not legal contracts, they are code. If you have any tangents with the crypto world, you'll see the concept code as law. Smart contracts try to be code as law. So basically, they are pieces of code that get written. You can have a team of people writing the same smart contract. You'll see when we get to the demo. and then you have to decide on all the aspects of the smart contracts before deploying it. But yeah, I just seen, if you check the chat, I forgot to mention it. Last time I created a cheat sheet. It was both for the first and the second session. So you can go to that link on Google Drive. It should be available. And you'll find a list of concepts that will help you before asking a question. Again, you can ask the question, but before asking the question, you might take a look at the cheat sheet and it might clarify some information. Coming back to smart contracts. So they are blocks of code, right? Again, written by a team and all that, but they are blocks of code. The reason why I use the term self-executing is because these blocks of code basically exist on the blockchain network, in the sense that once you decide this is the final form, you put it on the blockchain, and from then onwards, basically the blockchain communicates with it. You don't touch it anymore. So you won't have any tangent with it. You will just tell the blockchain, do this with this smart contract. Again, some things might clarify once we get to the demo. Another super interesting aspect of smart contracts is the fact that they are composable. So for example, I'll also give some examples later with like real life examples so that everything gets clearer. But the idea is that a smart contract is nothing but a piece of code. So for example, potentially you can have a smart contract that does something extremely well, and then you can use that smart contract in multiple other smart contracts, making something that I like to call smart contract Lego. Because basically you can have, I don't know, let's say we have this governmental list of who owns what properties. You can have a smart contract that specifically makes sure that it communicates with the government and it gets the owner of a property. And basically we'll have that smart contract which does this single thing very, very well. Then you can take this smart contract and implement it in your smart contract, which is, for example, making a buying contract for a house, right? Because the first step, you would need to certify that the person who's selling you the smart contract is the owner of the house, right? So then you can use this, it's composable. Okay, next thing is it's made by, used by, and implemented by anonymous, or if they want to be known parties. But the idea is the blockchain it won't discriminate. It doesn't matter where you're from, it doesn't matter who you are. You can make a smart contract, you can deploy it on the network, and anybody can use it. Good. Has behavior and state, or smart contracts have behavior and state. This is a slightly technical nuance to anything, to the whole aspect of smart contracts, but for the technical people here, yes. Basically, behavior means it has certain methods, certain operations it can perform, and state means that it has some content that it always remembers. Again, we'll see more at the demo. The next thing is that, like I mentioned in the first point, it's stored and executed fully on chain, which makes it untamperable. As we mentioned before, for example, in the case of Ethereum, after 60 minutes, the chance, oh no, actually after, yeah, I think it was like 10 confirmations, so 60 minutes, basically it's mathematically impossible to modify the data on chain. So once it's there, you can only execute it from there and you cannot change it. Okay, and regarding the example, I started building with, for example, buying properties. You need oracles. So blockchain, so smart contracts can only communicate with information that exists on the blockchain. So it can tell you what your balance is, it can tell you what that person's balance is, but it cannot communicate to the real world because it can only read from the blockchain because it has to do things in a secure way. The way you overcome this is by using an oracle. An oracle is a third party outside of the blockchain, which exposes some communication pathways for people, for the blockchain to communicate with it. And it has to be agreed by both parties executing the contract, in the sense that if I have somebody who wants to make, like I said, property purchasing contracts, smart contracts, and you're somebody who wants to use purchasing property smart contracts, we have to agree that yes, this third party is trustworthy. In our case, let's say we'll use the Romanian government. The Romanian government starts an oracle and it says, guys, whenever you call us to give you this information, I will always give you the truthful information. And obviously, if oracles are state level actors, you can trust them. Obviously, they can also be private companies. So for example, you can have information regarding the price of, for example, a stock from the New York Stock Exchange using a NASDAQ oracle. Moving forward, this slide is more about the benefits of smart contracts. Why we should use them, and I'm going to load all of them and then talk about them. The idea is, well, we'll get to the comparison later. What smart contracts has, like I mentioned before, since it's anonymous, it's deployed there, it doesn't have to be, it doesn't require trust. As long as you go to whatever the interface is and you want to execute that smart contract, it's by definition that you trust that entity, or else I would suggest you don't use the smart contract. So this allows for a trustless interaction. Also, if I create a smart contract, I cannot stop you from using it, right? So it's also a sort of, you cannot get stopped, I cannot get stopped to create it, right? Then secure execution. So everything is executed inside the Ethereum virtual machine. Basically, it's done on the computers that process the transactions. So from that perspective, it's in a secure execution environment. You won't be able to tamper with it. And by the way, if you try to do anything, the other machines will just test it. And if you do anything shady, they will find out. And this is not as much of a feature of smart contract, rather a type of smart contracts. And those are multi-signature contracts, meaning that if you want to execute any of the functionalities, you need multiple people to sign on it. For example, if you have a company and you have company funds, and those company funds can only be spent with multiple stakeholders accepting, you could create a multi-signature contract that does this functionality. And then you would need the key of the CEO, CTO, and COO, for example. Yeah, the next thing is you will get transparent fees and costs. Now, I'm sure some of you have heard that fees on the Ethereum network are volatile, and they are. However, when you, before you execute it, I'll also show you in the demo, it gives you what fees you'll be paying to the network and also what your costs are for executing that contract, including the action itself. Again, we'll see when we get there. And yeah, this is somewhat similar, is the predictable outcome and finality of the operation. Meaning that you know that if you click this, if it goes through, if it's a valid transaction, it's done. Basically, once it's done, you know it's done. So the bank can't come back tomorrow, for example, to you and say, yeah, you don't actually own that property, or we won't give you that loan. Because you'll be like, well, the smart contract executed on the blockchain, this is what the code says, you cannot take it back. Yeah, good. Now, as we already did some minor comparison, I'm actually going to do almost like a face-to-face between smart contracts and real contracts, but just slightly, not everything is a versus, but just like a small comparison. So we can talk about even the most basic utility of cryptos in general, but obviously we can expand it to smart contracts, and those are sending money. As you know, most of you know, until, I don't know, like 5 or 6 years ago, maybe 10 years ago, this was really, really hard. Like, we now get spoiled with Revolut and TransferWise and other financial instruments that allow us to do that. And even those, they're not fully across regions. Like, you can still have to wait a lot of time, like days, for transactions to confirm across jurisdictions. And that's because, yeah, there are a lot of safeguards in place, but most of that is just infrastructure, which is really, really old, and everybody is either afraid to upgrade or they just don't want to do it because it's super complicated. So the idea is that by default, crypto solves this because you can send these assets, but this also applies to smart contracts and transferring value through smart contracts. If you think transferring money from whatever, Romania to China is hard, try transferring property, if it's even possible, for example, to a Chinese citizen, right? So I haven't done it. I would assume it's not simple. If sending money isn't simple, I'm sure as hell that sending property isn't simple, right? Then you can think about legal contracts as an extension of this. Basically what I just said, sending money is something, just sending assets, sending a package might be hard. Think about transferring ownership of a company, of an asset, of anything, of, I don't know, intellectual property. I'm sure it's either impossible or so hard that you would need five third parties on top of it, right? Then you need trust. So for example, if even if there were a service, right, for me to go and say, I want to transfer the ownership of my property from Romania to, well, whatever, I'll stop using China, to Turkey, right? I would need to trust those companies who do that, in the sense that I would need to trust that they do what they do on their end. They're doing it in a legal way, so that I don't find out in 5 years I didn't actually transfer, you know, those assets. So this is different in smart contracts because you have the code there. Sure, again, you might communicate with a real world API, but if it ever comes to it, you'll be able to point at the information on the blockchain and said, look, dudes, for example, again, Romanian government, Turkey government, oracles, hypothetically, you'll be like, you gave me this answer when my smart contract interrogated your oracle and you said it's good to make this transition. So there's no backing up and nobody can modify that data. Insurance is super interesting because there is, like we'll see later, there are definitely risks for smart contracts. Most of them don't come with insurance. However, there are some parties that create insurance for smart contracts. And I think it's really awesome. At some point, I was actually considering getting some insurance. In hindsight, might have been good. But the idea is that you can have. So yeah, maybe I won't explain it now, but the idea is it's a smart contract that you apply, that you basically use, and it checks that you used another smart contract. And you say, well, the smart contract itself says that if anything happens with this smart contract, if it, or this account, if it has loss of funds because of this smart contract, it will pay you back. So even insurance is obviously done in a smart contract way, which I think is pretty awesome. The next thing is non-determinism regarding laws. Just like we mentioned, you're not sure how applicable stuff is. For example, you're not sure about the information of a contract that you make. You need to check. So for example, you want to transfer, again, ownership of an asset. You sign some papers. You don't know if those, they might go through. However, you might get sued. So the idea is that, and don't get me wrong, the legal system is fine from this perspective. Yeah, you do an action, if it's wrong, you get sued and you go to jail, whatever, that's fine. The idea is it's slightly not deterministic because in the terms of smart contracts, when we think about smart contracts, we implement them in such a way that there is no edge case. If this is what the law says, this is legal now. If it changes later, it won't affect me. So maybe, yeah, maybe this is interesting from a blockchain perspective, that you think that while laws can adapt and evolve, and by the way, smart contracts do this. So for example, if we have smart contract V1 and we want to move to smart contract V2, we can do that. We will just be using another contract altogether, and that's fine. So there are changes in smart contracts, but you do them in a new contract, and you say what happened, that those were the laws then. Now we move it to this contract, right? Okay. Another thing, just like we mentioned before, is speed, right? So I don't know, have you signed a contract on a Sunday? I haven't. Did it get processed? I don't think so. Did it get saved anywhere? I don't think so. So this is different on blockchain in general. I'm using Ethereum as an example because everything is in Ethereum in my demo and everything, but this applies to every smart contract blockchain. Basically, once you signed it, you execute it, and it's on the blockchain. It's in 6 minutes you have finality, and then you have in an hour you have permanence. So that won't ever change. This never happens for a contract. Nothing you do in the traditional legal system happens in minutes or hours or on a Sunday during weekends, right? The other thing is costs. For example, if you ask me how much does it cost me to move assets from, again, Romania to Turkey, I don't know. And I might speak to a third party. I would have to trust them to be legit. And then they could say it's 1,000 euros. And then in a week, tell me it's 1,500 because of X, Y, and Z. And I'll have to either accept that and believe him or not. This is not the case with smart contracts. Again, when you execute it, you have the cost, you have everything there. Once it happens, it's there. There's no extra costs you can see when you finish it. Well, actually, for example, there is something. For example, if you have a smart contract and you press, let's say, the deposit button and then the withdrawal button, you can have laws, well, rules, whatever, code that says that if you withdraw in the first week, you'll have to face a penalty. But again, that is visible there, right? So you'll see it's part of the thing you sign up for. It's not like a traditional contract that you can just amend as many times as you want. Again, like I said before, reusability. So smart contract Lego. This doesn't happen in the real world. I don't think any companies who said, yo guys, we already did this. It's super hard from the legal system's point of view. Here, have our contracts. Don't make yours from scratch. It's stupid. It doesn't happen, right? So from this perspective, I think smart contracts are really superior to real contract because yeah, you can just reuse them. And lastly, I said fraud prevention because again, once things are in the blockchain or rather on the blockchain, they're there. You cannot pretend to have assets, right? Again, with contracts. I've seen a lot of cases of fraud happening in the real world. I've seen some case like I think something like somebody sold the same properties like five times. How do you do that? Obviously, it's through corruption, and I'm sure they had some, like for example, legal actors in there, right, from representing the state or whatever, notary or whatever, however that gets done. But still, he was able to do that, which is absolutely insane. You're not able to do this on the blockchain, right? Okay, so as a small summary for this section, I'll make an example based on what we already spoke, right? So for example, you want to buy a house. If you look at the processes you need to do to buy a house, depending on where you are, they are super complicated. For example, in America, there is escrow. You basically put the money in a place, and then you take it out when it's done, or whatever, the third party takes it out when it's done, not the third party, the second party, right? So the idea is that these steps, first off, they take a lot of time, right? They have to be manually, or at least most of the things have to be manually accepted by an individual, by a person, right? They have to be signed off for. Sometimes you need escrow, you need to put the money in a place, the other person has to put the property in a place, or I think it's just the money, but you put the money in the place and then it checks that everything is fine, and only then the money is released. It's expensive because all of these steps I just mentioned mean that there are third parties, because somebody has to write the contracts, somebody has to look at the contracts, read the contracts, understand what's happening in the contracts, right? Sign off on the contracts. Then you need escrow. Somebody has to safeguard your funds while they're there. Somebody has to release your funds, take accountability of releasing your funds. And I'm not saying they're not useful. Obviously, these are tools to prevent fraud, and it's awesome. The problem is that these are third parties that get paid. Lastly, physical presence, wet signature. You have to be part of a notary, somebody who is, again, a representative of the state, who says that once we do this, once we sign this paper, the state recognizes it. And on the right side, we have the equivalent in crypto, right? So the crypto, you can have it done in minutes. It's all automatically finished once it's finished, right? It takes some processing time and confirmation times. Once it's there, it's there. There's no escrow because, well, it's just an if in a smart contract. If you have this money, or if you attach this money to the contract, if that person has a property, it transfers and that's it. So there's no escrow necessary. There's just processing. And yeah, obviously a fraction of the cost you have to pay the execution of the fee on the Ethereum network. Or again, just like somebody asked me the last session, yes, you can have a fee, a cost on your smart contract when you execute it. It's no problem. And you can be upfront about it. You want to charge 0.01% for selling a house? Yeah, that's fine. If it saves somebody $1,000, $5,000, $10,000, I think they'll sign off with 0.01% or 0.1%. So it's not all bad. I think it's a superior way to do legal and maybe legal transactions. I'll look at the questions right now. So if you have any questions, ask them now. Okay, so yeah, sure, absolutely. So Guillaume asked if theoretically could that be used to pay-per-view on blog posts, or since they're composable for product placement within blog post views? Yes, theoretically, yes. The idea is that, well, from a programming standpoint, you'll have to think of a way to do it smartly, because every time you execute, not a read, but a write on the smart contract, there is something there that there's a cost. There's a cost to executing any interaction with the smart contracts. However, specifically for what you asked, there's a browser, and we'll get to that a bit later, which is called Brave. In Brave, you get paid for seeing ads, and you get paid, well, no, you get paid for seeing ads, and company pay for those ad placements. So yeah, basically Brave has this implemented. I think it uses Solana in the backend, right? So they have a working solution. Okay, and now I'm going to answer another question. Hello, how a practicing attorney with limited code writing skills gets into smart contracts? Where should one start? And in general, is it worth it? So first off, again, I am just really passionate about this. I am a junior in this, right? So I don't have like production level experience with this. I haven't deployed a smart contract on the Ethereum Live net that everybody uses. So everything I say is from a theoretical standpoint. Igor, the thing is, I think the most use for attorneys will be once governments think that smart contracts are relevant, and they will have to rush to implement them if they see that the rest of the world is ahead of them. And I know that doesn't sound ideal, and it won't happen tomorrow, maybe. But once it does, the idea is that this will be super fast. So if anybody is building any type of, like I said, oracles with real life contracts and stuff like that, they won't need a lot of people. They will need, well, few people. And then, like I said, this will basically disrupt the whole law market, let's say, pretty fast. So I would suggest you get in touch with people who make smart contracts in general, be a bit attentive on the whole industry. And if you see any opportunity, jump on it. And just like with everything else, you're at the beginning, you'll have to make them understand that you want to do this. And it might not be that easy to get into, but that's the way you do it, just like with everything else. And regarding the code or no code, as an attorney, you don't have to write the code. People will write the code. Again, the code is complex. It's not necessarily simple, right? It's complex, but you'll have to just advise them on how to write it. If I can recommend you someone, maybe I can. I'll think about it. Okay, I'll think about it, and we'll talk about it at the end. Okay. So let's move on. Yeah, no problem. Okay, so now I'm going to talk about the risk, because I told you why I think they're awesome, but I have to tell you why I don't think they're that good, right? Well, not that good, but risky. Yeah, there are bugs. This is computer code. Computer code means you have to write it, you have to test it properly, and even then, you might have some bugs. You might have some vulnerabilities in your code. You might have some edge cases in your code, meaning that, again, you're human, this is code, it has to be properly written. The way it's done right now in crypto is you write the code, you test it, you'll see I have some minimal testing for my demo as well. You test it. Once you test it, you have an audit, which is a third external party. And only then, even then, you can put it on a test net. People can test it with test funds from the test net, and only then you release it. So the idea is, in crypto, the time to market for smart contracts is kind of slow, which is not a popular thing to say, but it's true. But it's because of safety. And you'll see people announce features 3 months before they have it, tell you it's done, and only get approvals from the audits 3 months later. Because again, it has to go through audit, it has to go through in testing. The next thing is governance risk. So the idea is that you'll see there's the concept in crypto called DAO, decentralized autonomous organization. The idea is that this DAO has like a governing role. Obviously, that's if you want to do it. So the DAO can change some of the rules of the game. This is basically democracy. It's still code as law, but it's like democratic code as law, in the sense that whatever you interact with, you need to be careful. For example, there were cases where some protocols were doing something, and because the actors that were using these protocols, the protocol community noticed that what they were doing was not okay, they changed the rules. Again, we have to go a bit deeper. Rules means you have to make a proposal, that there has to be a majority of people to accept it, blah, blah, blah. It's complicated, it's not easy, but governance risk is an actual risk because it can change. Now, like I mentioned before, multi-signature contracts. While it seems like a good idea to have multiple stakeholders be in charge of an aspect, they are at the end humans. So I'll show you some actual hacks that happened in the past. There were multiple of them that were made because of human error, because somebody has accessed either keys or wallet or actual individuals, and they just made them sign those contracts. Like, you get a prompt, and if you have access to that person's virtual identity, you can just confirm it. Obviously, you need everybody, or you need the majority. The idea is multi-signature contracts are risky because they can, again, just like governance, they can change the rules of the game. So you need to see that your protocol or the smart contract that you use, they are decentralized enough. If you see there's like a board of 3 people and they have a multi-sig contract which can change anything, yeah, I wouldn't suggest that is a good smart contract or a good protocol, because yeah, again, it might get hacked. Next, like I said, oracles. Oracles are awesome. However, they are external entities to the blockchain, right? So they can provide you with bad information. This is a problem on multiple levels. It would still be correct on the blockchain side. However, the word of caution here would be, make sure that the protocols you are using use oracles that you trust. For example, with the example I mentioned with the Romanian government, if you trust the Romanian government, that is, for example, right, you'll see that they vouch for this property. If they vouch for this property access API, then okay, use it. If there's some third party from, I don't know, an island who does the same thing, maybe don't trust them, even if they're an oracle. Yeah. And the risk at the end is also legal framework in the real world. Like, once, if we ever get smart contract adoption from the perspective of real world law, that is still changeable. That is not code as law. That's just, yeah, okay, we decided we're not going to accept, we're going to stop the oracle and we won't accept the information on the blockchain. That's a problem. And yeah, I think you can only stop this from happening by, I don't know, by democracy, right? You cannot stop it by just wishful thinking. And the blockchain will say you're correct. However, the court of law will say you're not correct. So this is a huge risk. It's less tangible than almost anything I mentioned, but again, human input. And now about prevention. So like I mentioned, audits, smart contract level testing, public test nets, and the one I haven't mentioned is open sourcing the code. You don't realize how many people actually try open source code. They go through it. They try to break it. There's the term of white hat hacker, which are people who want to hack things, but not to break them and cause damage, but just to test their skill, maybe get a bounty. And yeah, actually, this might have been a good point to have here, bounties. So in the crypto space, bounties are super important. Almost all blockchains, all big applications, they have bounties, and those bounties are significant. Like it can be multi-million-dollar bounties, you know. So you have to take the code, go through it, try to break it. And if it's, for example, something that could lead to loss of funds, there have been bounties of $3 million being paid, I think even more. So yeah, so prevention is possible, but it needs to be done right. Okay, like I mentioned before, there have been hacks. There have been hacks which were, again, human input, human vulnerability, code exploits, you name it. So there were multiple reasons why, why this happens. Did anybody hear about these, either when they happened or recently? This is a question if anybody wants to answer. If not, I'll just move on. Yeah. For example, I'll mention this one because it's interesting. Ronin network was actually a hack done by the supposedly done by the Lazarus group, which is the hacking arm of the North Korean government. Just so that you understand what kind of actors we're talking about here. So they noticed that there's this thing that it's working that has huge amounts of money in it, and they're like, okay, that's a target. And you just throw people at it, in the sense that you throw programmers and super smart people at it and be like, hack it. And they just brute force it and try every single door until they can hack it, right? So this happens. Okay, one of the things on the list here was the Poly network hack in 2021. I took this one just because I found this interesting graph about how it happened, and the outcome was actually quite interesting. So without getting into too much detail, this Poly network was supposed to be a bridge. So blockchains are like their own ecosystem. For example, Bitcoin cannot communicate with Ethereum, not by itself. There's nothing you can do to link Bitcoin with Ethereum. There are, however, implementations called bridges. Bridges basically have an entity here, right? An entity on each side. And once things happen, they just confirm it from the other side. So for example, I want to transfer funds from the Ethereum to the Bitcoin blockchain. I just say Ethereum, okay, this smart contract will block $10,000 worth of Ethereum. It will tell another smart contract on the blockchain network, which doesn't have smart contracts, to also release $10,000. The question you might have is, how does the Bitcoin blockchain smart contract has money? There are some liquidity providers in the back, but whatever, this is not interesting. The idea is, this is what the bridge is. Poly network was a multi-network bridge, and it linked the BNB chain, I think Solana and Ethereum, right? Basically, a really smart guy found a way to spoof the confirming node, I think it was on the BNB chain, to tell it that it actually deposited money on the Ethereum chain. And it just did this until he withdrew like $611 million. However, he returned everything, and he just said he did it for fun, and he did it to point that there were some vulnerabilities. I have seen cases where people have mentioned vulnerabilities before they happened. They either got immediately exploited, which is not good, or they got hacked later on, which is kind of bad, because if you have somebody who's smart enough to find the problem and tell you about it and you don't fix it, that's kind of your problem, right? Like, people should be able to adapt to that. That's why they have a bounty program. I think this guy was also offered a bounty, like $500,000, but I think he refused it. I later read that he might have been also charged with stuff, because it's not legal to attack networks. So from that perspective, I think he might be working for some governmental agency right now. I'm just gonna say it. Good. Let's move on. Okay, what's next? And not in terms of the presentation, but of blockchain. And the question is, the answer is Web3 is next. So you've seen what the internet is currently, what the internet currently is, and it's awesome. I really love the internet. However, can it get better? Some people in the blockchain ecosystem think it can get better, and this is Web3. Without diving into the details right now, Web3 is basically normal websites, but with smart contracts. So basically, for any functionality that you have in Google, you will have an equivalent smart contract, let's say, right? You will have an identity, which is your wallet. It's basically just like an account, nothing there. It's going to be decentralized. So instead of being on the Google Cloud network, you're going to be decentralized. Anybody can host a blockchain network. Anybody can open this front end, right? You'll see what I mean in the demo. It's permissionless. Nobody can tell you you cannot use it or you can't use it. For example, with Google, if you have a problem with Google, they can always say, yeah, you're not allowed to use your service anymore. And you'll be like, but it's my Google storage, it's my Google Cloud, I have information there. And they'll be like, yeah, you just can't use it anymore. And I'm not sure, but I think there's nothing much you can do from there because it's their application, it's their pipeline. You obviously have native payments, which is super interesting because basically what you have is anything can be paid for, or just like our friend asked, you could be paid for some action that you do, right? You have these DAOs, which is basically instead of Google shareholders or board of directors, instead of asking them what should happen with the Google platform, you will ask all the owners of this protocol, and you will have ownership of your data. So basically, nothing can happen regarding the information of your account if you don't agree with this. This can be abstracted behind the smart contract. Like I mentioned in this presentation, you can use it for finance, right? You can use it for computing, storage, bandwidth, identity, hosting. All these things are being done right now with Web3. Yeah, so these are some equivalents of Web 2 in Web 3. So for example, Dropbox, AWS S3, Google Buckets, you have blockchain protocols that do file storage. No problem, easy to do. You have the same thing with processing information, domain name systems, which is basically one of the key components of the internet, right? And then you have some various stuff like Spotify, there's Audius, Upwork, Braintrust, Medium, Mirror. It's, again, everything just like a normal platform. However, yeah, it's decentralized, it's Web3, it has all the advantages we spoke about. Now, for example, it can be slower to develop because unlike Google, you don't have a few $100 million to throw at a non-functioning social media product like Google+. And it's okay that they tried. However, as a low project, which is just getting started, you won't be able to compete with that. But that's why you have some venture capital firms inside the crypto ecosystem that try as much as they can to basically feed some money into this ecosystem, right? Yeah. So the future of the blockchain technology and Web3 as we see it is basically we might not need backends, because at this point, if the blockchain, if it's the database and if it also has computational power and you can actually run operations on it, then you don't need programming backends. You don't need programming languages that do these processes because you have the blockchains, which is quite a revolution because that means you will only have this front end part of business, right? You won't have to do the whole logic and storing and everything behind it. Yeah. With hosting, there is something very interesting called IPFS, Interplanetary File Sharing System. And the idea is that this is a distributed hosting system. It's super interesting. All of these, they're not happening right now, but they will happen in the near future. And the last thing here regarding my own reflection is, I remember when I started looking at crypto in 2017, and I look at where we are right now, like the speed at which things are improving is absolutely staggering. Like, my own personal opinion is that it's moving faster than general technology. There are some aspects of the tech world that are moving just as fast, but the adoption in the tech world is much slower. In crypto, if there is a smart contract capable platform of doing Y today, in a few weeks or months, you'll have almost all of them being able to do it, more or less, depending on how big the features are. And yes, for example, what happened with Ethereum with proof of stake, okay, merging from proof of work to proof of stake is hard, but other stuff like multi-sigs and stuff like that, they steal from each other super fast, which is a good thing, because you want all these ecosystems to provide tools. And as long as, well, you're not actually stealing code or anything, you're just stealing ideas. The thing is that this ecosystem is super rapidly accelerating. Okay, next we'll move into business considerations, because the idea is, okay, we want to make money. Everybody wants to make money. How could we use crypto to make money, right? Or why would it be beneficial from a business consideration, from a business standpoint, right? So first off, I'll talk about the developers a bit, and I'll just say that there are a lot of numbers, a lot of trends that show that obviously the developer market share is growing for crypto. As the market is currently down, probably those metrics are also descending. However, in the long term of things, you can check multiple sources. The idea is that the trend is super positive. There's super many people trying to join. And I think this is one of the most interesting graph here, is the fact that from the full-time developers in crypto currently existing, 45% joined in 2021. So at the same time, we're super early and it's super fast accelerating. Yeah, regarding salaries, they are super high, like, yeah. And some of these are like C-level or head of certain branches of companies level, which is good. Those are the biggest ecosystems in terms of developer counts and how many people they attract. Obviously, most of that is correlated with their value, but not necessarily, right? And at the time when I made this presentation, the first draft initially, there were, yeah, approximately 1,000 full-time developers that were responsible for over 100 billion in total value locked in smart contracts. That value went down, obviously, because the whole market went down. The idea is that the number of people working to secure and create that value is actually quite small. So if you look at it, if you have a super smart business idea and you wanna access a lot of funds, you don't need so many people to do it with. And I'm just coming here from the perspective as a developer. You don't need, for example, backend developers in this particular case. You just need some front-end developers and some smart contract developers, and you have a working project. Which, if the business case is good, if it's secure, if you have traction, if you can make some well, positive and like real hype around it regarding how good it is, you can basically capture a lot of value, which I think is a good thing. Next, I'll talk about what you could do in crypto to have a business, right? Just like our friend asked earlier regarding how he could get into this, I'm going to tell you guys what could be done here in terms of what business could form here, right? So the idea is validating. Just like we said last session, currently there are multiple proof of staking nodes, then proof of work. There are some proof of work, but the industry trend is proof of stake. Proof of stake means you have validators, not miners, meaning that validating is a viable way to make business here, because as the trend of crypto is to get as decentralized as possible. Basically, we need multiple validators. So setting up and managing validators is a good business to go into. It requires sysadmin and DevOps skills. So basically, you need to be able to set up machines, configure them, and make sure they're safe, right? The next thing is, for example, is having a application-specific blockchain on Cosmos. Cosmos is a blockchain which also provides an SDK, which is a software development kit. Basically, from my knowledge, Cosmos is the easiest way to create a blockchain from scratch. So potentially you can have your own blockchain with the specificities of Cosmos, which is really good because you don't need to, you don't need to think about the whole blockchain logic from scratch. You can just use Cosmos, which is super, well, it's old in sense it's reliable. Next is obviously writing smart contracts. You can try to, find individual clients you can write smart contracts for. You can actually basically try to provide consulting from them. Try to think of it from terms of what their customers might need, what you can offer and stuff like that. Basically build the business logic for the smart contract, and then you have developers just implement it, right? Everything around smart contract, like auditing, testing, external of just what the internal devs have done. Okay. Another thing is obviously Web3 development. So creating full applications on whatever blockchain you want. You say Ethereum or Solana is the best blockchain. We are there. Okay, let's make an application. Fine, you can replicate any business existing in the real world in the crypto space. You might have a viable business on your hand. Then you can do educational stuff, just like the ones I mentioned. Education is super important. Crypto is at the beginning. Starting an educational company for crypto right now might be a really good move from the perspective that you have a head start. If this programming paradigm, let's say, or if this phenom actually goes mainstream and becomes the norm, you will have a huge head start, and educating people is super important because people are scared of new stuff. I remember seeing some graphics regarding the creation of the car from the 1990s, right? Well, it was created before, but the idea is that I was seeing stuff like, I don't know, the wind demon, and they were trying to demonize cars because they were afraid of cars, and probably there was some horse riding lobby who was actually paying money to discredit cars. But this is somewhat similar. If we think as a collective that crypto is worth it, we are definitely at the beginning. So, and if you get in at the beginning, you'll obviously have a better chance of succeeding than later. And just like I said, consulting for everything else. And I just see that the sun is exactly in my face. Well, yeah, we should be done soon anyways. Good. Now we move to demo. The question is, for the demo, I actually want your input. And your input is, where do you want me to deploy the smart contract? A, in my local network, or B, on the Ethereum testnet? Because the idea is I can do it anywhere and it's almost no difference, and you will see. Okay, so the Ethereum testnet, cool, awesome, let's do it. So first off, I'll go through the code a bit. This was the test, and you can read it. So again, I'm sorry if it's code and if it's scary. First off, is it visible enough? Should I increase the font? Cool. Okay, so this is the smart contract. All in all, this is how it looks. It's a it's a text file that has code in it. You can have some shorthands, you can have functions, you can have all of that. If you're not a programmer, that's fine. The idea is that, for example, this is the state. Well, not this, but all the variables are the state of the contract. And then you have the functions, which are the behavior of the contract. So basically, you'll see better probably once we start the application that we can, whatever. I'll just go through one of the methods. Again, even if you don't understand programming, just follow me and you should be able to understand it. You have the function that is deposit. That means we will be able to call this deposit function from our interface, and what will happen is exactly what I described here. For example, it's a payable function, which means I can attach financial value, in this case, Ethereum units, to it. And those Ethereum units will be added to this contracts balance. Contracts can have balance. What I also do is for the internal internal bank balance that I keep, I add the message sender, which in this case will be me. I will create a link to it and the value it has deposited. Basically, this structure will keep an internal book of what user has deposited what value, right? And lastly, I will also add it in a transfer history just for the sake of easy to see, right? This is not necessarily important. And at the end, I do some console logs, which is just logging. Obviously, you don't do this on the live networks because yeah, you won't be able to see anything. Basically, this whole smart contracts, the functionality is simple. The contract itself has a stored value. I am able to deposit or withdraw money from my own personal, let's say, record, or I can deposit money into somebody else's account. This is like a mini bank. The idea, yeah, it's like a mini bank. For example, with, like I told you, deposit to, I can have an address. I want to deposit some money. I can deposit their money. I can have some withdraw. I have some rules. For example, if the balance for my address is more than what I'm trying to deposit, you will see that we'll get an error and all that. And there are some helper functions. What else? We have the whole application. The application itself is written in React. React is, yeah, basically it's a front-end engine, right? It's a front-end language. You don't have to, let's say, you don't have to understand it for this purpose. You'll see that it's just a nice, interface. Well, I hope it's a nice interface. And sorry. Okay. And we'll soon have the thing running. Yeah, the idea is that right now it's basically starting the whole server. It wasn't running before, but it won't take long. And it will process everything that has to do with, obviously, the front-end side. Right? Okay. And this is my front-end. Sorry, it's still loading a bit, but yeah. This is my front-end. So basically, this is just the graphical interface. Right now, we don't have the backend connected to it because we have to connect to the Ethereum testnet. Again, some of these configurations are obviously made beforehand in my project because, yeah, we won't be able to do it on the fly. The idea is that the functionality itself to deposit is really simple. And 1 second, let me just search for it because there are multiple commands and I just have to find which one is the right one. Yeah, look at my nice interface until I do. Okay, I found the right command. This is the right command. So again, this is just computer programming stuff. The idea is that, okay, sorry. Okay, that means, yeah, I changed the name of the things yesterday, sorry. So it's deploy bank. Yeah, the idea is that we can actually see the functionality here. What it does, again, I won't bore you with the details. In the backend, it takes this contract that I've written, it does some packaging, it stores something, on my local PC. Why? Because it needs a record of how the contract looks. This is just for the purpose of interacting with the contract better. It's a protocol called gRPC, doesn't matter. The idea is that, yes, once this is finished, basically it told me that it finished deploying, and this is the address of the smart contract. And I should be able to open it. And of course it will open in another browser. But the idea is that right now, and I think if you want, I can publish this link so you can see it in the chat. Basically, this is me. And don't worry, I don't actually have a lot of money in my contract, and I actually need to change the network, but I'll show you that this is basically my address. So the transaction hash, whatever, the person who created this contract, which is this one, this is my own account. It's obviously configured in the backend inside my code to be the author of this contract, but the idea is that this is me. And this is on the Reimagine testnet for Ethereum. And it's live. So right now, potentially, if you wanted to create your own bank app and you say, okay, Adi's interface is trash, okay, I accept it, right? I want to make my own interface, but I'll use exactly the same smart contracts because, yeah, the smart contracts aren't that bad. And you could do exactly this. So basically, you would be able to just use my smart contracts on your platform, create your own interface, and that's it. Which I think, again, is kind of neat. And this is the same way you would use the composability Lego that I mentioned before, right? You would be able to say, I want to use this, this contract. So this right now, this is the address of the contract. So basically, you can do whatever you want in it. We can always check for this contract, and you can see right here, it has a balance of 0.1 Ether. Again, it's test Ether, right? When I deployed it, I also added 1 Ether to it as a gesture of goodwill, right? So right now I have my MetaMask account. Yeah, and by the way, don't bother stealing anything. It's just test account. I don't have any money on these wallets. If you see anything sensitive, but whatever, there won't be anything. And sorry, let me just. This was the thing for the local network. Okay, Reimagine. Okay. I have a password, right? You can obviously have a password for your stuff. And this is my account. No, this is my account. And it says I'm not connected to the interface, which is true. And you can see my address here, which I think it should be this address. And it is. So you can basically see that, again, I didn't use MetaMask to create the wallet, but this is definitely my wallet from the testnet, which I configured in the code to be the deployer of my contract, right? So again, like I mentioned, this is anonym. However, yeah, if you know that this is my address, you will know when I deploy certain contracts, which, you know, that's what I said. It's pseudo-anonymity. It's not actual anonymity. Okay, and let's go to the implementation. Okay, Adi, we're tired of this. Okay, I can show you that currently this reads what the current balance is of the contract. Okay, and like I mentioned, this is the Ethereum testnet. It's actually not that easy to get Ethereum on the testnet, but I have some, right? I have 0.38. And it's actually connected to a wrong address. And this is just because when I implemented the code, this wasn't one of my, and let me just check which one it is. This wasn't one of my strong suits because that wasn't the purpose of it, right? This is more about user experience kind of deal. I wasn't trying to get any specific user experience for this. It's just for the purpose of demonstration. So again, this is my wallet. This is my address. I'm not connected. I connect. It will ask me if I want to connect with which account. I say I want to connect with this account. Okay, connect. Now I'm connected. It shows that my personal balance. This is basically the balance that the code stores right here. So basically it says, Adi, the contract itself has 0.1 ETH. You stored nothing. So yeah, for example, I'll even try to do the withdrawal first, just so that you can see, and I will try to withdraw 10 or whatever, yeah, 10, right? And it says error. And I didn't bore you with the details of why it failed. We can check the logs if you want, but the idea is the Ethereum virtual machine does like a pre-run, and it checks that, yeah, even before trying to access the network, it can just do some reading and tell you, okay, you don't have this balance. Actually, just for the sake of it, I'll show you that inside the, well, if it only would come up. Oh, sorry, it's on the other screen. I was curious. I think we should have the error. Ignore the errors, they're not relevant. Look, this is basically, again, it throws the correct error. I just didn't handle it properly. Execution reverted, trying to withdraw more money than you have deposited, which is basically exactly the rule which I set right here, right? So again, it did this even before trying to do anything on the blockchain. So it does a virtualization. Okay, let's say I'm actually legit and I want to do, well, I don't have a ETH. Well, this would also point to an error, but yeah, I don't have one ETH, right? So that won't even work. I can put 0.1 in because I have. So like I mentioned in the thingy, yeah, seed network is busy. So that means that if it's busy, you can pay more for gas to have it to have it processed faster. Doesn't matter, we won't need it. However, just like I said, this is a gas estimate. It's mostly correct, but it tells you ahead of time how much you're going to pay on the gas. And at the end, you can see this is just the gas cost, and it will say you'll pay 0.1 what you want to deposit into the balance of the bank, fine, plus the gas fee, also fine. It will also tell you the max amount you'll pay. In this particular case, because it's the testnet, it's probably a bit more predictable. So this is basically the max, or maybe it's a setting. I'm not even sure about this, right? Confirm. We will have a confirmation once it's done. But yeah, since it's congested, let me just close this. Mining, okay. Since it's congested, it might take a while. Okay, it's here. So by the way, I implemented some UX changes. So basically, when the transaction got confirmed, I didn't put any notifications. However, the balance that does upload. We also have messages here, and you can see that I did a self-deposit. This is, again, directly from this record. So again, this is super bad implementation in the sense that all this information can basically be obtained by querying the blockchain, because you can see the whole history, you can see these aspects. But I just did it just as a, as a thing. So yeah, this is it. So right now, the contract has 0.2 ETH. By the way, if we refresh it, we can see it in the Etherscan. Again, this is on the testnet. It's fully live. Like I mentioned, you can see the full history. So that's why I said this is redundant. If you have a good reader of this information, you can do it without. However, since it's inside the smart contract, it's obviously more safe and it cannot be tampered, and you don't need a third party to make sure that what you're reading is correct, right? Yeah, and I want to withdraw it, obviously, right? Withdraw it. And again, I'll be asked for the confirmation, the same thing with the gas, max gas, whatever, whole cost. As you can see here, I'm not paying anything. So basically, I'm just paying for the gas to execute this smart contract. I'm not moving any money. Therefore, this contract is not payable. I'm not sending 0.1 ETH so that I can unlock 0.1 ETH. No, it doesn't work like that. I confirm it. And yeah, once it's done, you'll see that both the general bank balance and my personal balance gets cleared. And also, I didn't show you this. Right now I have 0.27. You just saw how it modified to 0.37. So basically it removed the money I put in the bank, it transferred them back into my account. Yeah, this is basically it. This is basically the end of the presentation. I still have some slides, but the idea is that this was my demo. This is how it works. I think it's quite neat. I think it's quite interesting to do, right? Yeah, and in terms of the presentation, do you have any questions regarding anything you just witnessed? Yes, I will actually, yes, this back. No. Okay, whatever. Yeah, there's actually this is what I was talking about when I mentioned risks and prevention. You can have a local Ethereum network. That's why I said you can. Oh, actually, yeah. Thanks for mentioning it. I can actually show you the test. The test, like I mentioned, is super simplistic. However, I will get it done, and I'll show you how that looks. And that is test.js. Okay, just test. Basically, what it does is it starts a whole blockchain, mini blockchain network for the scope of this test. It runs whatever, not here, sorry, this is the wrong file. This is the correct file. It runs whatever test I ask of it, and then it shows me the results. Sorry for being so clumsy. Yeah, whatever. I can run it again. Not here. So yeah, the idea is that you can run tests. So basically, you can test it to as close of a real environment to the Ethereum network as you can get. It's locally. You can see even in more depth what happened, how it's working, why it's working, what's not working. So you can have a test-driven development in which you test edge cases and stuff like that. Good. Okay, sorry, Bogdan, can you clarify, what do you mean, when do we start our app? Which part of the app, to be more precise? Okay, so to answer until Bogdan answers, so yeah, basically what I did is I ran it on the Ethereum test network. However, and this is what I wanted to show you, I also have, so that's why I asked. There was also a C option, but I didn't provide it because it was, well, redundant. I can run npx hardhat node, I think is the command, and it will run a command line interface spoof Ethereum network. And this is it. It started it. And it gave me accounts with keys with that 10,000 Ether as a balance. Right now, I can actually change my code in my browser, right, in my application, to use this specific network for my operations, right? Or this is what I wanted to show you is I can also use Ganache, which is, again, it's a tool. And yeah, basically, it's a visualization of the whole Ethereum network running on our machine, right? You can see addresses, you can see balances, you can see keys. It's awesome. And also you can see even blocks and transactions. And this is from the past because this has state. This remembers its history. I can wipe it, but it by default it remembers. So I can see everything that was ran. I can see the transaction hashes, I can see the addresses, I can see what was executed, I can see everything, right? Oh, okay, now I understand, Bogdan. Well, dude, hit me up after this. maybe we can get something started. Yeah, I'm happy you enjoyed it. So how much time to make a dApp that uses Aave to lend money in a bank smart contract? I don't know. So the question, the correct question is, how much access do you have to the code, to the smart contracts of Aave? And in the case that you have access, you would just need to run the dApp around the Aave contracts. I'm not sure if everybody here knows what Aave is. Aave is like a automated market maker. Well, I think probably it's a whole DeFi protocol. I think at this point, right? So basically, it can do trades and stuff like that. It has liquidity pools. So basically, depending on how complex this implementation would be and what you would need from Aave, it could be or it couldn't be done. For example, if you need money from a liquidity pool, you won't be able to, again, smart contracts are composable, but you're not able to have your own logic inside the existing smart contracts. You can only have logic around it, right? So yeah. Sorry, if you have further questions, just ask them. I'm just telling you what comes to my mind. Oh, also I see a question, what are the cons of this technology? Like I mentioned, even in the risk section, there are risks, there are cons. Cons, I mean, again, if you mean risks, I already presented them. If you mean cons, I don't think there are a lot of them besides the risk. I mean, if you think that having code as law that gets executed anytime you want to execute it, that's permanent, I cannot see a con of that. Like I said, I mean, a con could be the privacy stuff, right? It's pseudo-anonymous. So that means that if you know my address, you can basically track my whole financial history. I guess that's a con. Maybe some people don't want that. However, you can abstract this by using a new wallet, right? You can use, for example, a centralized exchange, put your Ethereum money there. From there, send it to a Ethereum wallet, and then use that wallet to interact with a dApp, right? With a Web3 application. And then nobody will know who you are. Well, the only people who can actually trace your identity is the people from the centralized exchange. So yeah, again, might be some cons. I think risks are more important than cons, but yeah. Other questions? If that's all, I'm not seeing any other questions. I think we can finish it. So guys, if anybody has any other questions, feel free to search me on, I think LinkedIn maybe is the best way to find me, right? My name is Adrian Padurean Octavian. If you have, some people from the last session just hit me up there, asked me questions about blockchains. That was awesome. So yeah, by all means, I really enjoy talking about this. So just ask me questions and I'll be more than happy to help you guys. And yeah, I hope everybody had a good time. I hope I didn't speak too fast and you understood stuff. The purpose of this whole thing is raising awareness. So if you live here with knowing more about blockchain and smart contracts, I'm happy. Also, my colleagues have provided a form, which it would be cool if you filled it in so that we know some feedback about the session. So yeah, guys, thank you for everything and have a good day. Bye.